Good evening, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So, guys, as you know, Ground Zero series is going on. In that, we are having some animations to tell you the concepts, and this is the live practice session. And here we will see the practice questions on the topic welding. This is the topic from which every year we are going to have one numerical in the paper in general. Okay, so we are starting this session. So guys, just like and share the session, and if you are watching me for the first time, my name is Dheeraj Sardana. I am having around 10 plus years of experience, written many research and review paper, qualified exams, and this subject going on is production. So guys, now without wasting the time, we will start the questions. But before that, an important announcement for all of you that on 9th of April 12:30 p.m. a wonderful workshop will be there. So if you are preparing for GATE 2024 or 25, or any of your relative or friend is doing that, he can attend this free workshop where 7 proven tips and techniques to GATE 2024 will be taken by Abhinav Negi sir, who is from MTech IIT Delhi, 10 plus years of teaching experience. So guys, you can join this workshop for free, and at BYJU'S exam prep app it will be available. You can register for free. So moving further, guys, so this is the very first question, guys. So the very first question, you can see I will be telling you how to solve. Okay, first of all, let us see the statement of the question. Okay, so guys, when we are talking about this question, this is from the arc welding, obviously. Okay, as we have seen arc welding only. So a direct current welding machine with a linear power source characteristic provides open circuit voltage. So guys, I feel everybody is knowing that what is open circuit voltage. This is the voltage between electrode and workpiece when there is no current flowing. So at that time it is given that open circuit voltage is 80 volt, and short circuit current is the condition electrode is directly touching to the workpiece and current is directly flowing to the short circuit. At that time also welding will not take place. It is 800 ampere. If I show you the graph between voltage and current, then my dear, the graph is going to be like this. So this voltage is said to be open circuit voltage. This is said to be the short circuit current. Open circuit voltage is the voltage for zero current. Current is the highest current for zero voltage. So they are given to you. And if you are going to write the straight line equation, you can write V by V naught plus I by IS is equals to 1. You know the straight line equation, X by A plus Y by B is equals to 1. You can also write it as, if you will be writing, V will be coming out to be V naught, that is open circuit, minus V naught up S into this to be the equation. Okay, and that is said to be the distribution of a transformer who is following this linear voltage or current characteristic. They have mentioned that the measuring currents is 500 ampere. They have said the current is 500 ampere when the arc length is 5 mm, and they are saying that current is 460 when the arc length is 7 mm. So you know, whenever this electrode towards the workpiece, this arc length will be varying, and when arc length will be varying, voltage will vary. When voltage will vary, you know, current will also vary. So we know one thing, that relation is given, V is equals to A plus BL. This is the relation between voltage and arc length, and we just need to calculate A and B, and we are aware of voltage arc length characteristic. Whenever we are talking about, they are coming like, okay, because more the gap will be there, more voltage will be required, because for more gap, more resistance, so we will be requiring more voltage for the flow of current. So my dear, if this is the thing we have already seen, we just need to find out. You know that the equation says V is V naught minus V naught by IS into I. So my dear, V can be written as A plus BL. And you already know open circuit voltage is 80 volt minus short circuit current is 800 ampere. So 80 by 800 into I. So it is already mentioned that when arc length is given 5 mm, then the 500 mm. So we will be having A plus B into 5. It will be 80 minus 0.1 into 500. So this will give you the equation 80 minus 50 is 30. So A plus 5B is 30. This is equation number 1. So my dear, now we will be having the second equation on the same concept when we 4. The second equation is going to be A plus B. Time if you see the question, it is going to be 7 mm. For 7 mm current is 460. 7 mm, 7 mm. Current is 460. It is 80 minus 0.1. It is 460. 460 into 0.1 is 46. So we can write here as A plus 7B as 80 minus 46. 80 minus 46 will be, I feel it is going to be 34. Yes. So we got two equations now. Very good, Kiran. Good evening, dear. How are you? Kaise aap? The answer is correct. A plus 7B is 30. A plus 5B is 30. When you will be solving this, you will get A as 20, B as 2, and the equation will be coming out to be 20 plus 12. So A is going to be the right. Very good, Kiran. This is the first question which is coming in the paper, and I feel you go. So guys, we need to have such questions in this session. This is a 30-minute practice session where we will see all ESE paper. So we are going to see the second question now, and this is the second question, and this time the same equation would be used. I am fine, Kiran, and if possible try to connect with me within a day or two whenever you are free. Okay, I also wanted to talk to you. So in a DC arc welding operation, the voltage arc length characteristic, this time we are going in opposite way. In the previous question, we were knowing open circuit voltage, we were knowing short circuit current, and we need to find out the voltage arc length characteristic. In this question, voltage arc length characteristic is given, and we need to find out the open circuit voltage and short circuit current. So if you see in a DC arc welding operation, the voltage arc length characteristic is given as 20 plus 5L. So V is equals to 20 plus 5L is given, and where the arc length is varying from. So arc length is varying from 5 mm to 7 mm. Okay, so that is for sure that when arc length will increase, voltage will increase. When arc length will decrease, voltage will decrease. That is a well-known fact for us. Okay, and you know they have also mentioned that V arc denotes the arc voltage. The arc current varied from 400 ampere to 500 ampere. Now you know whenever we make VI characteristic as linear, when voltage reduces, current increases. So voltage and current have inverse relation because power is V into I. So definitely when voltage will increase, current will decrease, and when voltage will decrease, current will increase. So my dear, that we need to decide that 400 ampere is for which voltage and 500 ampere is for which voltage, because they have not mentioned anything. They have said when arc length varies from this to this range, current varies from this to this range. Now that you need to decide for which arc length, which current you have to take. So guys, you can see when arc length increases from 5 to 7, current should decrease. So for L5, for L7, so you know for 5 mm, for 7 mm, arc length increases, current should decrease. So here current should be 500 ampere, here current should be 400 ampere. And you need to find out the open circuit voltage and short circuit current. Those who already know the concept can try. Otherwise, I am going to solve this question for you. Very good, Kiran. So Kiran have already answered it as C. So I would like to say that the Kiran have answered it correctly. 95 volt and 950 ampere is correct. But let me show you how to solve this. You already know the equation we have seen in the previous question. You can V is equal to V naught minus V naught by IS into I. Okay guys, so we do not know V naught, we do not know IS. So we will assume V naught to be, let us say, X. And this is V naught by IS. Let us say this to be. So we have these two variables. Okay, let us say we need to find out these two. Okay, so if you need to find out these two, what will be the equation? V is already given as A plus BL, that is 20 plus 5L. 20 plus 5 is equal to X minus Y times of I. So my dear, now you just need to put the values when L is going to be 5 mm. 20 plus 5 into 5 is 25 is going to be. It is X, the current is 500 for 5 mm. 500. So X minus 500Y. Equation number 1. Then we will be going for the second equation, that is 20 plus, this time arc length is going to be 7 mm. So 5 into 7, it is equals to X minus, this time current is 400. So you can write 20 plus 35, X minus 400Y. So one equation is this, other equation is 20 plus 25 is equals to X minus 500Y. So this is equation 1, this is equation 2. When you will be solving these two equations, you will get X to be 95 volts, Y to be 0.1. So when you will put the Y value, Y is nothing but V naught by IS. So you will be getting IS as 95 by 0.1. It will be coming out to be 950 amperes. Very good, Kiran. Wonderful, dear. So really happy to see the solution. You have done it. So the answer will be C. Okay. Now, my dear, we are moving to the next question. Question number 3. This is one more type of question which is coming in GATE exam. Here you need to tell for maximum arc power the current should be set as. Here I will also give you a thumb rule for this question, this type of question, where just by looking at the type of question you will be able to answer. Okay, so let us see how many of you give the right answer for this. The question says a DC welding power source has a linear voltage characteristic with open circuit voltage V naught 80 volt and short circuit current of 300 amperes. You need to find out the current for maximum arc power. Okay, I feel Kiran once again have given the answer, and according to Kiran the answer is 150 ampere, and I am saying yes, the answer is correct. So guys, let us see how to solve this type of question. Yes, optimum by 2 is the answer. Very good, Kiran. So you already know the equation for voltage was V naught minus V naught by IS into I. This is the equation. It is 80 minus 80 by 300 into I. This is the VI characteristic, as you already know. And we are also aware of one fact, that power is given as V into I. And if power is given as V into I, we can write the power to be 80I minus 80 by 300 into I ka square. This is when we will be multiplying I with the V. We will be getting this. So guys, this is the equation of power. Now we have power in terms of current. So we have only one variable, that is current. So if you want to get the optimum power, you know, if I want Y to be optimum and if Y is a function of X, then I will be going for dy by dx and equating it to 0. So here also I will be going by dp by di and I will be equating it to 0. And then I will be getting the value of I for the maximum power. So when you will differentiate it, you will get 80 minus 80 by 300 into 2I is equals to 0. So my dear, this 2 will be giving us 150 here, and be taking this to the right hand side, you will I to be 150 amp. But now I give you the thumb rule, like if we have open circuit voltage as V0 and short circuit current as IS, and someone is going to ask you optimum power, then the answer will be V0 by 2 will be the voltage for optimum power, IS by 2 will be the current for optimum power. So you can directly answer like this as well. Okay, so from now onward you need not to solve this question, just you can directly answer it, because by differentiation you will get this. Okay, so you can see this question, the answer is 300 by 2. Okay, so now if you will use, if you put in this equation, if you put this 150, the voltage will come out to be 40 volts. Okay, I hope everyone got it. So moving to the next question, guys. Moving to the next question. Okay, this is one more type where you need to answer about the arc length in mm. Okay, so this is all these are of more or less similar type of question, but they are coming in the gate examination. Okay, so like in ground zero series we are coming up with very small but animated video to show you the process, and in the live session we are coming up with the practice sessions. Yes, try to solve it. The voltage arc length of a DC arc is given as E is equal to 20 plus TL. Here L is arc length in centimeter. They are saying here L is length in centimeters. The power source characteristics can be approximated by a straight line, as I already told you, means VI characteristics will be like this and arc length characteristics will be like this. Yes, that's correct. Open circuit voltage, okay, I feel Kiran have answered it as C. Okay, very good, Kiran. So open circuit voltage is 80 volt. Short circuit current is 1000 amperes. Okay, yes. Very good, Kiran, very good. So now how we will do this? We got this value. Now my dear, you need to find out optimum. So power is V into I. So we can also write it as 20, okay, sorry. So first of all, we have the voltage, okay, we have the voltage, and we know that we can write voltage as open circuit voltage minus open circuit voltage by short circuit current into I. This is the equation. So power will become 80I minus 80 by 1000 I ka square. This is the power. So some students are going to put the value of voltage in terms of arc length. Then it becomes difficult, because then everything will be in the terms of L, will become lengthy. So rather you solve it in the same way like we have done in the previous case. Even you can directly use the optimum voltage. You already know open circuit voltage is 80 volt. So optimum voltage is going to be 40 volt by 2. So 40 volt you will be equating with this, you will get the value of L. But still I am going with the complete procedure. Now you will be going for optimum power. So for power optimum you will say dP by di. So when you will be going for dP by di, it is 80 minus, it is going to be 80 minus 80 by 1000 into 2I. So when you will say 2 will get cancelled out by 500. Okay, so from here you can definitely find out the value of I to be 500 amperes. So when you got this value of I, you know V is equals to 80 minus 80 by 1000 into I is 500. So you will get the voltage optimum as 40 volt, as I was already saying. So once you get this optimum voltage, V optimum, you will be writing it as, what is the equation for us? The equation for us is 20 plus 40L. So you will say 20 plus 40L, and this is going to be optimum. You will equate it with 40 as 20, 40L optimum. So you will be getting 20 by 40 is optimum. So you will be getting L optimum as 0.5 centimeters. So my dear, this 0.5 centimeters will be 5 mm. So the answer for this question is C. I hope everybody got it. So the answer for this is going to be C. So Kiran have given the right answer. So moving to the next question. I hope you guys will be enjoying the level and the type questions. This is an easy question now. So this is just to check that whatever I have taught you questions, you learned it or not. So after this, we will see 1 to 2 more questions. Okay. So not very big session. We will go for 10 to 15 more minutes. The question says, the DC power source for arc welding has the characteristic as 3V plus I is equals to 240. So he is saying 3 voltage plus I is 240. This equation is given to us. V is voltage, I is current. For maximum arc power, for arc power to be maximum, you need to see the voltage. This is the question. So let us see how many of you give the right answer for this one. I feel this is the 5th question we are doing in a row. One question is there from gas welding as well. One theory question is also there based on the applications. Okay. Solving, trying, Kiran. Okay. So I am giving you hint how to do this. So you have 3V plus I is 240. You can write 3V as 240 minus I. V will be 80 minus I by 3. So this is the equation. Very good, Kiran. Kiran have answered it as 40 volt. B. So you got this equation. When you will go for maximum power, for that, first of all, power is V into I. So you will say 80I minus I square by 3. So when you will go for dP by di, as usual, 80 minus 2I by 3 is equals to 0. So 240 by 2, I will be coming out to be 120 amperes. When I will be coming out to be 120 amperes, you will put it here. 120 by 3. 80 minus 80 will be 4. So B is going to be the right answer as Kiran have said. So the similar it is not a different concept. The similar question, here they have asked a different manner. So if the similar question is coming in different manner, then also you must be in a position to solve such a question. So I hope everyone got it. Moving further to the next question. Okay, I feel this is the similar question once again. So let us skip this and move to some new type. Let us say now we will be doing first this question. This is a good one. So let us see how many of you will be able to solve this one. A gas metal arc welding process is used to join 2 mild steel plates with the following welding process parameter. Current is 220 amperes voltage is 24 volts, welding speed is 19 centimeter per minute, wire diameter is 1.2 mm, feed rate will be 4 meter per minute, thermal efficiency is 0.63, heat input per unit length, it is kilojoule per centimeter. You need to answer this, okay? And they're asking the area of cross section of weld. You need to answer this. Assume the duty cycle means arc is switched on throughout the cycle time. So if you see this, my dear, first of all, I feel, okay, if you want to try, you can try it. I will give you 1 minute. So this is a wonderful question. If that kind of question will be coming, it will be coming for 2 marks. For such question, you can use the units and dimension part. Like, you know one thing, that power is given as V into I. They have given you current, they have given you voltage. From here you can find out 220 into 24. So this will give you the units of power will be joule per second, which is nothing but the watts. So you will be getting the power in watts. Okay. Okay. So Kiran have solved this question as well. Kiran, very good. So according to Kiran, the answer coming is B. Okay. So let us see how to do. So Kiran, can you tell me the value of this power? You will get this. This is joule per second. You can also call this as heat generation. Now some efficiency is given. You can write, okay, you can write 63 as efficiency of heat input ka rate by heat generation ka rate. So you will be getting heat input ka rate as 0.63 times. What is that? What is that? This is 220 into 24. 220 into 24. So this is having the units of joule per second, but we want the units to be in kilojoule per centimeter. Very good. So this is 5280. This is 5280. So when this is 5280, so you are having heat generation ka rate, and this is heat input in joule per second. So if I want heat input in kilojoule per centimeter, what I feel is, first of all, this 0.63 into 5280, this is in joule per second. So this is in joule per second. So to make it in kilojoule per second, I will divide it by 1000. Now it becomes kilojoule per second. Now we already have the velocity, the speed. Speed is nothing but 19 centimeter per minute. So first of all, we need centimeter, but we need in second that. So 1 minute is 60 seconds. So 90 centimeter per 60 seconds. So we can use this and we will put it 19 centimeters in 60 seconds. So second will get cancelled out. And you will be getting the heat input in kilojoule per centimeter. And that will be coming out to be. So Kiran, this, okay, let me check the question. Question is asking kilojoule per centimeter is 10.5. Very good, Kiran. So it will be coming out to be 10.5. 10.5 kilojoule per centimeter. Now, my dear, when the welding is going to take place, like this is plate 1, this is plate 2. So obviously some wire is getting melt. So this wire is going to fill the weld bead, obviously, okay. So if this is the area of weld bead, we can write area of weld bead into velocity, okay, into velocity of welding. That can be equated as pi by 4 dw, wire diameter square, into feed rate. Why? Because whatever this wire is coming, that is going to fill the cavity, that is going to fill the weld bead. So in that case, we can equate them, both have the same unit, and you will be getting the area of weld here as 23.809. 23.809 mm square. So this type of question, if it will come, will be coming for minimum 2 marks. Okay, so we have done this question number 6 as well. So now, my dear, we will move to a new question that is related to this gas welding. Now you need to answer this question on gas welding. Okay, and we will be concluding the session at this question, and telling you one thing, those who are appearing for BARC examination, we will be coming up with BARC practice session. Actually, we are coming on alternate because we wanted you to revise. So one day you are revising, second day we are giving practice session to you. And one more thing I would like to tell you guys, that after that also many opportunities will come. And if you are looking for 2024, then my dear, you shall not wait anything. You shall prepare, and if you want any guidance, you can connect with me on Mechanical by Dheeraj Sardana Telegram channel. There I will be guiding you if any help you are seeking for. Okay, like related to your preparation, related to notes, related to practice material, related to previous year's question, everything I can help you with. Okay, Kiran is saying B is the answer for this. So guys, first of all, I am writing the Telegram channel link. Those who want any support from my side can join this. I will also give you contact Mechanical by Dheeraj Sardana. Just search that in the Telegram and you will get this channel. Join this, and there you can directly connect with me. I will share my contact number also. Notes are also given. PDF of this session will also be given. So during gas welding, oxy-acetylene neutral flame. So I would like to say there are 3 types of flame. One is neutral flame. So first of all, for 1 mole of C2H2, complete combustion requires 2.5 mole of oxygen. But we will not be giving the complete oxygen, otherwise arc will not be produced. In place of welding, combustion will happen and we will get the energy, like IC engine things will happen. We want not a complete combustion, we want flame to be produced. So we will be providing always less oxygen. So if we are providing acetylene and oxygen in the ratio of 1:1, it is neutral flame. If we are going to provide that in a ratio that acetylene is going to be less than oxygen, and generally the ratio is going to be for oxidizing flame, and if C2H2 will be more than oxygen, this is said to be the carburizing flame. So guys, this is how the types of flames are divided. Okay, so this was the practice session, guys. So we will be coming up with more such sessions after every topic and subjects, and you just go to the video section of this channel to see the animated videos of various topics which we are making for you guys. So for the timing, goodbye for this session. We will be meeting again for such sessions. Goodbye, good night to all of you.